Example 3. Analyze the continuity of the function f at x equals 1 over x at x equals 0. Well, here we have a reciprocal function, and if we were to sketch a reciprocal function, it would look something like this, where we'd have a point at 1, 1, maybe that's about there. We'd have a point at -1, -1, maybe about there, and then it would get close to the y-axis but never touch. I'll do this in a different color. And it would get close to the x-axis but never touch. And the same thing in quadrant 3. It'd get close to the x-axis but never touch, and close to the y-axis but never touch. So this is our reciprocal function, y equals 1 over x. And we want to see what happens at x is equal to 0. So let's explore what happens as x approaches 0 from the left-hand side of our function 1 over x. And we can see from the graph as x approaches 0 from the left-hand side that we are going to start to approach negative infinity. And as we approach x equals 0 or x to 0 from the right-hand side of our 1 over x, we can see that this is actually going to approach positive infinity. So these are not going to meet at the same point. Now we know based on limits that the limit is not going to exist because the limit from the left-hand side doesn't equal the limit from the right-hand side. So the limit as x approaches 0 of 1 over x does not exist. And now we need to think about what type of discontinuity this is. Well, because one is going to negative infinity and one is going to positive infinity, or the fact that they're going to infinities at all, we call this an infinite discontinuity.